Students, how are you? This is our lecture number 9. And in this lecture, we have to start momentum actually. But before we start momentum, let's quickly go through small detail what we missed in the last class relevant to movement first. And then we will jump to momentum, right? So, what exactly we missed, we will discuss that related to movement. The first important part is, as we have discussed previously, that moment is a vector quantity, right? So when moment is a vector quantity, it means that there are two type of moments we have it. Let's suppose if an object has a pivot here, means fixed point at this point, there can be two options that even if you apply a force in the downward direction, it will rotate about this point in clockwise direction. And if you apply a force in that way, it will rotate about this point in anti-clockwise. So technically speaking, there can be anti-clockwise movement and a clockwise movement, right? Now, as far as sign conventions are concerned, we are taking clockwise movement as a negative and anti-clockwise movement as positive, right? Now, there are two, three things which are very, very important at this point, which we have to discuss. So the thing is, let's suppose this is an object, right? If I apply a force of 2 Newton in the upward direction, and in the same line of action, I apply a force of 2 Newton in the downward direction, where this object will go? This object will be in stationary mode, right? Or you can say these two forces will balance each other. This condition, when forces are applied, but they are canceling each other and body is in stationary mode, we call that as equilibrium condition. So equilibrium means when sum of all the forces acting on an object at a point is zero. Mathematically, we write it like this: summation F is equal to zero. It means all the forces acting on a point on an object will be equal to zero. Sum of all the forces. This is called a summation sign. Now, this is one of the conditions of equilibrium, means when the body is in stationary mode. But there is an other condition as well, and that's what we called as law of momentum, or you can say momentum condition. Momentum condition, condition of moment. When you talk about momentum condition, you can simply say that in momentum condition of sum of all the torques, sum of all the moment, zero. What does it mean is that sum of, you can say sum of clockwise moment is equal to sum of anti-clockwise moment. It simply means that if the movement, clockwise and anti-clockwise movement, are equal to each other, we call that a law of, we can simply say that a moment condition. In this condition, what does it mean? That it's also one of the equilibrium conditions. So one condition is summation, all the forces acting on an object at a point is zero. And the other condition is sum of all the moment acting on a point, or acting, you can say acting on an object about a point is equal to zero. Normally we write it like summation tau is equal to zero. Tau means moment or a torque. So basically, this will be the condition as well. Now, let's take an example, then you will understand it. Let's suppose you have condition. This is a bar, which is fixed from one point, right? And there is a force acting here. Let's suppose this force is F1, and the distance, perpendicular distance from the fixed point to the force is D1. There is another force which is acting in the upward direction, F2, and the distance from the fixed point is D2. Now, the equilibrium condition says, and we are saying that if this rod is in equilibrium, it means sum of clockwise moment is equal to sum of anti-clockwise moment, right? Now, if you check it out, this force is acting in downward direction and it will rotate this rod into clockwise direction. So let's write it down. Clockwise moment is equal to F1 D1, and this force, because upward, so it will rotate about this point in anti-clockwise direction. So anti-clockwise moment can be given as F2 D2. And if this rod is in equilibrium, not moving, that can only be possible if anti-clockwise moment is equal to clockwise moment, which is F1 D1 is equal to F2 D2. Or you can say F1 D1, and because clockwise moment is always taken as negative, so F2 D2 is equal to 0. This is one of the equilibrium condition. As summation forces at one point acting on one point is equal to 0, you can say this is called moment, right? Which says that sum of all the moment acting on a point, acting about a point, a fixed point, is equal to 0, right? Now, let's have one question so that we will understand what exactly this situation is. You can see yourself. He says that a parent and a child are at opposite ends of the playground on a seesaw. The weight forces acting on the parent is 6 Newton, 60 Newton. So she is, let's suppose weight is definitely the force, so 60 Newton. And the weight acting on a child is 140 Newton. So F2 is 140 Newtons. The adult is sitting at a distance of 0.3 from the pivot. So this distance is 0.3 meters. And that distance, they didn't give it. And I think this is the distance they're asking you to find out. The question is this. The one is the adult sits on that and they're asking you that how much is that distance be so that both will balance each other. Now, how to do this? We know that if this is a pivot, that parent will try to rotate about in anti-clockwise direction about this point, and that child will rotate about this point in clockwise direction. So anti-clockwise moment is equal to clockwise moment. They are asking you how far the child will sit so that both will be balanced. So anti-clockwise moment will be 690 multiplied by 0.3, and that child is 140 multiplied by D. So D will be equal to 690 multiplied by 0.3 divided by 140, and that will definitely provide us the value. Let me take out the calculator and solve it. It will be what? 690 multiplied by 0.3, and that will be divided by 140. So it will come up as 1.47. So this is the distance, 1.47 meters. So child needs to sit from the pivot 1.47 meter, so that the weight of a child and weight of this adult will balance the situation in such a way that this rod will not rotate, right? So this is how you need to solve it. And this is what the anti-clockwise and clockwise movement is all about. So this is one of the conditions of equilibrium as well. So there are two conditions, and this is also called as moment condition, or law of movement. This is also called as, right? This was the one which was missed. Now let's start with a new topic, momentum. Now, when you say momentum, what actually is momentum? So momentum is technically amount of motion present in a body, right? Mathematically, it can be given as momentum is equal to mass multiplied by velocity, right? If you ask me what is a unit for that, the unit will be kilograms meter per second. So this is the unit of momentum, right? So if somebody will ask you what is momentum, you have to tell them that momentum is a product of mass and velocity. It is a vector quantity having a direction, right? Because velocity has a direction, so momentum has a direction as well. So what is momentum? Actually, it's amount of motion present in a body, but mathematically, you can say that momentum means product of mass and velocity. Unit is kilogram meter per second, and it is a vector quantity. It has a direction as well. As I just give you an example, let's suppose there is a car. Now I'm giving you an example. There is a car, right? That car has, let's suppose, a velocity of 5 meter per second, and the weight is, let's take it an easy example, 1000 kgs, right? It goes there and strike, and then rebounds with the velocity of 3 meter per second. The question is, what is the momentum of car before and after collision with the wall? Now, this is interesting, right? Before collision, you can simply say when the car is going on the right hand side, the momentum will be 1000 multiplied by 5. So it is equal to 5000. And the unit is kilograms meters per second. That is before, right? What about after? After, momentum will be 1000 multiplied by. Now, this is interesting because the velocity is the rebound velocity. Direction of the velocity is different. So you can say that the velocity is -3. So momentum will be negative 3000 kilograms meter per second, which means minus sign shows that the direction of the momentum will be opposite direction, right? So this is some basics of momentum and moment we have just finished. In the next lecture, hopefully that will be lecture number 10, we will discuss further law of conservation of momentum, and there are few more small definitions which we will discuss, and we will see to them how the things are. And I hope you understand that. Hope to see you in lecture number 10, which will be our next lecture. So for thank you for hearing the lecture. Hope to see you next time. Take care. Bye.